Everywhere we go, we encountered a lot of trigonometries, but we don't know what is the meaning of it. Did you know that in early 70s, if you knew trigonometry, you'd probably be a navigator on a ship. A good navigator can discover their location even in the middle of the Atlantic Ocean with some trigonometry and a good clock. To further discuss what is trigonometry, let's watch this video. Come on and join me.
Good day everyone! In today's video, we will talk all about trigonometry. Come on and join me, let's go!
Like mathematics, more than 4,000 years ago, mathematicians in Egypt, Mesopotamia, and India's Indus Valley developed trigonometry. The measurement of angles, minutes, and seconds can be traced back to the Babylonian basic numerations. Then in about 150 BC, Hipparchus created a trigonometric table that used sine to determine the solution of triangles.
As early as 1150, Bhaskara provided exhaustive instructions, complete with sine and cosine formulas for generating assigned tables for any angle. Bhaskara developed the trigonometry of the sphere. Nasir al-Din Tusi and Bhaskara were the first people to recognize trigonometry as a distinct branch of mathematics. Nasir al-Din Tusi initially provided a list of the 6 instances of a right-angled triangle in spherical trigonometry.
What is trigonometry? Trigonometry is a branch of math that looks at specific angles and how they can be used in calculations. In trigonometry, an angle is often used for 6 different things: sine, cosine, tangent, cotangent, secant, and cosecant are their names. In the figure, you can see how these 6 trigonometric functions work with a right triangle.
There are 2 different types of trigonometry. These are the plane trigonometry and the spherical trigonometry. Plane trigonometry deals with the relation between the angles and sides of triangles, of which the 3 vertices are located on the surface of plane and the sides are straight lines. A straight line being the shortest connection between 2 points on the plane.
Spherical trigonometry involves the study of spherical triangles, which are formed by the intersection of 3 great circles carved on the surface of the sphere. Spherical triangles are subjects and can study from antiquity as are very useful in navigation, cartography, and astronomy.
I think we've had enough of explaining what trigonometry is. But what about how we do it? I'll explain.
But before I can explain how to solve trigonometry, let's first identify its parts. This is a right triangle, and this is a theta. If a given is opposite to the theta, it's called opposite. If a given is below the theta, it's called adjacent. And if a given is opposite to the box, it's called a hypotenuse. Now let's move on to the other 3 functions. But first, we need to be familiarized with the expression SOHCAHTOA. SOHCAHTOA are the formulas of each function. So means sin theta is equals to opposite divided by hypotenuse. Ka is cosine theta is equals to adjacent over hypotenuse. And TOA is tangent theta which is opposite divided by adjacent. These 3 functions have their own reciprocals, which are cosecant, cosecant and cotangent. Cosecant is the reciprocal of sin. Secant is the reciprocal of cosine, and cotangent which is obvious, is the reciprocal of tangent. Finding these three formulas aren't that difficult, because the only thing you need to do is to flip the reciprocals function. So cosecant is equivalent to hypotenuse over opposite. Secant is adjacent over, hypotenuse over adjacent, and tan and cotangent is opposite over adjacent. Now let's move on to solving trigonometry. With a triangle of two sides, we need to find the 6 trigonometry functions. However, there's a missing side. So one way of finding this missing side is to use the Pythagorean theorem, which is a squared plus b squared is equals to c squared. Four squared plus 9 squared is equals to c squared. The square root of 4 squared is equivalent to 16, and 9 squared is equivalent to 81. Sixteen plus 81 is 97. We must square root both sides, which becomes 9, which makes 97 9.8, which makes our opposite 9.8. Now let's identify its functions. Sin theta Sin theta is opposite over hypotenuse, which makes it 9.8 over 9. The cosine is 9 over 4. Wait, I was wrong with this one. I just realized it's 4. So 9.8 divided by 4. Now, tangent is 9.8 over 9. If we were to add the reciprocal of each, cosecant would be 4 over 9.8 secant would be 4 divided by 9. And in tangent, which is cotangent, nine over 9.8. Let's move on to another example. If we have a triangle of 7 and 10, we'll have to find the third side, which is a squared plus b squared is equals to c squared. Then squared plus 7 squared is equivalent to c squared. Ten squared is equivalent to 100. 7 squared is equivalent to 49. 100 plus 49 is 149. I'm sorry, wait. Now we will square root each side. Which makes it 12.2. Its sin function would be ten over 7. Its cosine would be 12.2 over 7. And its tangent would be 10 over 12.2. Let's try a different approach. What if you have a missing side, such as Judging through this given, I think that the function that we should use is sin, because we have a opposite and a hypotenuse. Sin theta equals to 42 over x. Now to solve for this, the only thing left should be x. So in order to do that, we have to multiply 42 by both sides. Which makes it x is equals to 42 sin 65, because our theta is 65 degrees. Using a calculator, the outcome would be the answer would be 38.06, which means that our x here is 38.06.
And that concludes our trigonometry vlog. Hope you've learned from this video and try to look out for any trigonometry examples, because as James Joseph Sylvester says, mathematics is the music